Hi, this is Tom Loschiavo, Chemistry Education Manager at PASCO Scientific, and I wanted to introduce you to the Advanced Chemistry Sensor. The Advanced Chemistry Sensor is designed especially for chemistry. It's a new multi-measure sensor that can measure pressure for gas laws, has a port, can measure pH, pH probe, conductivity with a 10x conductivity probe, and temperature. It comes with a stainless steel temperature probe. So because it has all these measurements, I can make all those measurements individually or simultaneously. So we're going to look at a very simple reaction, but see that we can get complex information out of it and really tie in some broad concepts in chemistry. So in the solution here I have just some acetic acid, and I'm going to add an Alka-Seltzer to it. So first we'll look at the pH. So over here I'm going to start my data collection of pH versus time. And it's a weak acid, so I have a low but not too low pH. I'll add my Alka-Seltzer. And we get our characteristic bubbles of CO2 forming. And we can see that the pH is changing because of that, the Alka-Seltzer being an antacid, or a base in this case. And we'll auto-scale this and we'll see that how the pH is changing. There's a pretty dramatic rise in the pH as the reaction proceeds, the bubbles form, and the acid is beginning to be neutralized. But now the interesting question is, what else is happening in this reaction? So you can ask your students, what's happening to the temperature? What's happening to the conductivity? And now, because of the simultaneous measurements, we can see all of that at once. So let's take a look. I'm going to stop my data collection. And now I'm going to look at the temperature. So again, asking students to predict what happened. And then you can reveal that, after we auto-scale it, that the temperature was actually going down the whole time. So after I added my Alka-Seltzer, temperature is going down because in this case it's an endothermic reaction. As the CO2 is being produced, energy is being absorbed by the system. So now what's happening to the conductivity? Again, tying in some big concepts of acids and bases, thermochemistry, and electrolytes. So we'll go to the conductivity page. Now we have conductivity versus time. Again, we'll auto-scale this so we can get a better look. And the conductivity was low, and it shot way up as the reaction proceeded because you were reacting a weak acid, which is a weak electrolyte, and you're adding in sodium bicarbonate, and you're producing the CO2 and some sodium acetate. So now I have some ions in the solution, or more ions in solution. So my conductivity increased. So you can really get at a lot of the chemistry concepts with a very simple system as long as you can make all those measurements. And that's what the Advanced Chemistry Sensor allows you to do. Now the really nice part about this is, since I was making those measurements simultaneously, I can view all of them on one graph. And I can make connections between what was happening in each of those properties. So we'll look at our next page. And we'll auto-scale it. So now we can see, my pH, which was my Y1, was increasing. At the same time, my temperature started dropping. It's my Y2. And the conductivity started to increase. So we can, again, tie in all those concepts with a very simple process as long as we have the data to analyze it. Now in chemistry, we often want to look at a reaction like this where we understand the amount of reactants added. And typically we do that with a titration. So I'm going to open up some data from a titration that I performed. Now this was a titration of hydrochloric acid with sodium hydroxide. A very simple acid-base titration, strong acid, strong base. And I used the Advanced Chemistry Sensor so I can make simultaneous measurements. And I used a drop counter in the other port of the sparkling air. So the advantage of the sparkling air is it allowed me to use both of those sensors at the same time. So here's the pH curve, typical of what you would expect, very, very classic pH curve for a strong acid-base titration with our equivalence point somewhere around 7. But again, the interesting thing is I can look at lots of other stuff at the same time. So I can look at the temperature. So now we can see, oh, this is an exothermic reaction and can tie in thermochemistry and acids and bases. Reaction kept heating up, giving off heat, until the equivalence point was reached, and then the temperature started to go back down as I just essentially was diluting the titrant that I added. And I can also look at the conductivity. So this is the thing that you can't normally do. This is this sort of nice thing about the advanced chemistry sensor. Now I can tie in conductivity with pH and temperature. So my conductivity started high, got lower as I was producing more and more water until the equivalence point was reached, and then I went beyond the equivalence point and I was just adding more of a strong electrolyte titrant in sodium hydroxide. My conductivity started to rise again. And again, because of the multi-measure nature of this, I can look at all those things simultaneously. And this is really where the big ideas can come together. So here's my graph of pH, it's my Y1, temperature, my Y2, the red one, and conductivity, the Y3. And I can see they all meet up at the same point where the equivalence point was reached, and that's where the inflection points for those graphs were. So with this new advanced chemistry sensor, I can have access to lots of chemistry concepts, both individually and simultaneously, because of the measurements I can make, the software I can use, and the analysis that I can do. So, thank you very much for watching. If you have any questions, please feel free to reach me at chemistry@pasco.com, and have a great day.